Friends, let us understand Coulomb's law of electrostatic force. According to Coulomb, if you have two charge is Q1 here and another charge is Q2 here, then these two charge attract or repel each other with a force, and that force F is directly proportional to the product of magnitude of their charges. This means that proportional to Q1 Q2 magnitude, and this distance between these two charge center is R. So this force is inversely proportional to square of distance. This means that combining you have F is proportional to Q1 Q2 upon R square. When you remove this proportionality, then you have to give a proportionality constant which is K, and Q1 up Q2 upon R square, where K is proportionality constant and where value of K is 1 by 4 pi epsilon naught, which is equals to 9 into 10 to the power 9 Newton meter square per Coulomb square. K is proportionality constant and epsilon naught is said to be permittivity or absolute permittivity of free space, and its value is 8.854 10 to the power minus 12 Coulomb square per Newton per meter square for vacuum. So this is said to be Coulombian force between two charges. So you can write F is equals to K Q1 Q2 upon R square. Here Q1 and Q2 are magnitude. This is equals to 1 by 4 pi epsilon naught Q1 Q2 upon R square. This is said to be Coulomb's force. Let us have some questions based on this Coulomb force. Question number first, which is many times asked in the examination, that what is the dimension of K and epsilon naught. You have to find the dimension of K and epsilon naught. So number A part, dimension of K is equals to the value of K is 1 by 4 pi epsilon naught, and here in this formula the value of K comes to be F R square upon Q1 Q2. Give a square bracket for dimension. Dimension of force is ml t power minus 2, and dimension of R is L2. Dimension of charge is AT, it is AT. So you have m L to the power 3 t to the power minus 2 t to the power minus 2 here, and 1 minus 2 will move upside, it become minus 2 minus 4, and a to the power minus 2. This is said to be dimension for K, part number A. Part number B, you have to find dimension for epsilon naught. Dimension for epsilon naught. So here this is epsilon naught, and you know that part number B, you know that K equals to 1 by 4 pi epsilon naught. So epsilon naught dimension is equals to 1 by K dimension, because 4 pi is constant. K dimension is here, this is 1 by m L to the power 3 t to the power minus 4 a to the power minus 2. So this come to be m to the power minus 1 L to the power minus 3 t to the power plus 4 a to the power plus 2. This is dimension for epsilon naught. So you have learned about the dimension. Now let us have a numerical based on Coulomb's force. Numerical number 1. You have a charge here Q1. You have a charge here Q2. Let Q1 equals to Q and Q2 equals to also Q. Let us distance between these two charges R. Let there is a charge Q3 whose value is 0. Now hold the charge Q3 and just touch to the charge Q1. After that, touch to the charge Q2 and remove it. And the distance between Q1 and Q2 become half. Then what will be the new force in this system? For that solution, first of all, we write the force F. Force F is K Q1 Q2 upon R square. So this is K Q by R square, which is K Q square upon R square. This is the force for case number 1. Now what case number 2 said? Case number 2 said that there is a charge Q3 having charge 0. So when we touch Q3 to Q1, then due to conduction, there is equal distribution of charge because their shapes are same. So Q1 dash is equals to Q1 plus Q3 divided by 2. So this is equals to Q plus 0 divided by 2. This is Q by 2 and this is said to be Q3 dash also. Now Q3 dash have acquired charge Q by 2. Q3 dash is touched to the sphere Q2. So Q2 dash is equals to Q2 plus Q3 dash upon 2. So Q2 is Q and Q3 dash is Q by 2 upon 2. So here you have 3Q upon 2 by whole 2, which is equals to 3Q upon 4. This is said to be Q3 double dash. Now the distance between these two charges become half. This means that now Q1 is here and Q2 is here. This is dash, and this is R by 2. In this case, now force F dash is equals to K Q1 dash Q2 dash upon R upon 2 whole square. So you have K Q1 dash is Q by 2. Put here Q by 2. Q2 dash is 3Q by 4. Write here 3Q by 4. And here this become R square upon 4. This 4 will cancel out. So you have K Q square upon R square. Here you have 3 upon 2. This K Q square upon R square is F. So this is equals to 3 by 2 F. So the new force become 3 by 2F. Let us have another question for you. Second numerical. This is numerical number second. Suppose you have a charge capital Q here. This is an important question. Many times asked in examination and in competitive exams also. This is capital Q. Let at the center we place charge Q. So distance is x. This is point A, this is B, and this is C. You have to find the charge Q value when these three charges are in equilibrium. Then the question is, these three charges are in equilibrium, then what is the value of small q charge? For this, at equilibrium, you have force on A due to C plus force on A due to B. This is equals to 0. So what is the force on A due to C? This is K capital Q upon 2x whole square. And what is force on A due to B? This is K capital Q small q upon x square, which is 0. So you have K Q square upon 4x square is equals to K minus here K capital Q small q upon x square. K will cancel out. 1 q will cancel out, x square will cancel out. So you have small q equals to minus q upon 4. Thus the charge small q equals to minus q upon 4. For upcoming video, do like, subscribe and share my channel. Thank you.